It's Mr. Sladke talking about the flip lesson 5.1 on pre-calculus. Don't forget to take notes today in this. This will be a lot easier if you have some things written down. You can pause if you need to. Okay, first of all, let's talk about what's coming up in this chapter. This is on exponential and logarithmic functions. Today's lesson is composite functions. We're going to talk about one-to-one and inverse functions, exponential functions, logarithmic functions, some properties, some equations. All right, so we do all that. And then we talk about the applications of these, 5.7, 5.8, 5.9. We do have a quiz right in this section, right after 5.4. So here, and then we have a test over the whole chapter. All right, let's talk about composite functions, which is what section 5.1 is. We're going to be at the grocery store, all right, and apples, let's say, cost 40 cents each. We want 10 of them at 40 cents. We get $4. Let's figure out the tax. At 8% of $4, we get 32 cents. We add them all together, we get $4.32. We're going to combine these two things, the cost and then the tax. Okay, these are two functions, composite, like composite rocks. There's two different types of rocks in the one rock. Well, this is composite functions. All right, well, in this case, we have an input of 10 apples. The rule, let's call it f of x, is 40 cents per apple. So the output is $4. We take that $4 and we put it in to a different function. And that function, we'll call it g of x, the tax rule. It is, we have to pay $4, the initial amount again, and then we have to pay 8% tax on the item, the total amount. So in this case, 8% of $4 is 32 cents plus their initial item is $4.32. Let's look at in this way. Okay, so we have our two functions. We're going to find f of g of 10. That's exactly what we just did, actually. We put 10, it's actually, we did g of f of 10. We actually put 10 into the function f. That's the order. You do the inside first. And so that's 10 times 40 cents each is $4. And then g of $4 is 1.08, the tax amount. G of $4 gives us $4.32. Okay, so you can see how we do this. The order does matter. If we said, like I originally had, f of g of x, we'd actually be doing the tax function first and then putting the result into the f function, which doesn't make any sense. All right, so that one is no good. All right, let's talk about some examples you'll see for homework. Let's do a couple kind of easy examples with numbers. Okay, find f of g of 4. Okay, another way to write this is f of g of 4. So find g of 4 first. Okay, let's do that. We'll do that mentally. 4 is here over 4 minus 2. We actually end up getting 4 over 2. So g of 4 turns out to be 2. Okay, then we take f and put 2 into it. 1 over 2 plus 4 turns out to be 1/6. So that's what happens with that one. Now let's find the next one. G of f of -3. Put -3 in for f. So that'd be 1, if you're thinking about it like g of 1 over negative 3 plus 4, which becomes g of 1 over 1, 1. Okay, g of 1 turns out to be 4 over 1 minus 2, so that's 4 over negative 1, or negative 4. Alright, so just a couple examples like that. Now, what you're going to be asked to do is find f of g of x, kind of the rule of the function. Okay, so we're going to take and we're going to put g of x, and we're going to put that into f. Alright, so we'll do that. That gives us, this is f of g of x is equal to 1 over 4 over x minus 2 plus 4. Okay, so we have some simplifying to do. I'm just going to write equals here. We have to get a common denominator. 1 over 4 over x minus 2 plus 4 times x minus 2 over x minus 2. We did this last week. Equals 1 over. Now we can combine. This is 4 plus 4x minus 8 all over x minus 2. I'm getting closer. I'm going to do it over here. Turns out to be 1 over 4x minus 4 all over x minus 2. Let me remind you that when you divide complex fractions, it's like saying 1 divided by, and I'm going to factor the top out to be x minus 1 over x minus 2. When you divide, you actually invert the second piece to be x minus 2 over 4x minus 1, and you get x minus 2. Oops, we got. Did I already invert it? I already inverted. Yes, sorry. X minus 2. You get x minus 2 over 4x minus 2, and that's your result. Okay, so that's, you'll get some question like that. And then the domain question of this is saying this. Okay, what's the domain of f of g of x? Well, automatically the domain of g of x is, it can't be 2. It can't be the denominator 0. So we already know that it's x such that x can't be 2. But there's more, because we know that the end result with f, it can't be negative 4. But we say g of x, the end result cannot be negative 4. So we just solve that. 4 over x minus 2. It can't be negative 4. We just solve this. This is over 1. And we get 4 times negative 4 equals x. That is 4 equals negative 4 times x minus 2. That gives us 4 equals negative 4x plus 8. That gives us negative 4 equals negative 4x, or x is 1. So the other thing it can't be is 1. Okay, we'll cover that one more way so you can understand it. I just had to ask you a question first. Parallel lines have so much in common. It's a shame they never will meet. Oh, I know. It was bad. Okay. Here's the same exact question. Find the domain, but in a different way. Remember, we said that f of g of x was x minus 2 over 4x minus 1. Remember that we resulted in that, so there's another way you could find this. First, it's the inside. It can't be positive 2, so it can't be that. So x such that x can't be 2. And then you look at the result of f of g, and we know the result says it can't be 1. So x can't be 1 as well, and that's your domain of this. So if you actually find f of g in this process, you can actually find the answer as well. So, thanks for watching. Good luck.